Okay, so we were going through the topic of travel time studies. Yesterday we completed one example with the running time and running speed and travel speed. Then we discussed a little bit about travel time contour maps.
I already have cards.
Okay. So then we discussed the time space diagram. Okay. And the last thing which we were doing was control delay studies. Okay. So in control delay means that the delay which is caused because of the time in the queue, because of deceleration, and because of acceleration, time required to accelerate back to the normal speed. Okay, so control delay includes these three things: time in the queue, deceleration, acceleration. Okay. Then I explained to you the procedure for observing or doing the observations for delay on a signal. Okay, and the procedure is given in the highway capacity manual. And we need how many observers? Two, right? Okay, one of them is measuring the vehicles which are in the queue. You give him a time interval, and after each time the time interval passes, he will measure or he will count how many vehicles are in the queue. The second observer is recording how many vehicles are arriving and how many of them are stopping. Okay. Once you have these observations, then you can move on to the calculations of the control delay, starting with TQ. TQ means time in queue delay. Okay, or the time spent in queue. So we need here IS. IS means the interval which you gave to observer 1. Okay, so you told him count number of cars in the queue after every 10 seconds. So I is 10 then. If you told him do it after 15 seconds, then I is 15. Okay. Then VIQ is the observation which this observer is noting down. Okay. So he starts observation. Now there are 5 vehicles in the queue right now. So VIQ is 5. After the time interval passes, he counts it again. Now he sees 6 vehicles in the queue. So VIQ is 6. Okay. So if he is doing it for half an hour, he will have many observations. Okay. So that's why we are doing the summation. Okay. Summation means you will take his observations from all time intervals, you add them together. Then we have VT, which is total number of vehicles which arrived at the intersection. Okay. And which observer is doing this? Observer number 2. Okay. The first two values IS and VIQ from observer 1, the VT from observer number 2. Okay. The next thing we calculate is VSLC, vehicles stopped per lane per cycle. Vehicles stopped per lane per cycle. Okay. So I need what? Vehicles? You just woke up. What happened? Huh? How come I'm here today? Huh? Yes. We need what? Vehicles stopped. Okay. Per lane. So I need number of lanes. Okay. Per cycles. So I need number of cycles. Okay. What do we mean by a cycle? Yes. Yeah, start of one red to the start of the next red. Now here we are not putting the time of the cycle. We are putting the number. How many times the red signal was repeated? Something like this. Okay, so how many times the signal completed the entire cycle? Okay, not the time of the cycle, but how many times it happened. Clear? Okay, so these three things. And then we have the next thing, which is fraction of vehicles stopped. Fraction of vehicles stopped. So I need vehicles stopped. And what was VT? Vehicles arriving. Okay. And who is making these observations? Huh? Observer 2. Okay. Both of them are from observer number 2. Once we do this, then we can calculate the control delay, D. Okay. So D is our final value. Okay. So we need TQ, which is what? Yes. What is TQ? Time in Q delay. Okay. What was FVS? Yes. Fraction of vehicle stop. Okay. Both things already calculated. Then we have a factor, correction factor, CF, for which you see the table below. Okay. So in this table, we need the free flow speed. Okay. Free flow speed should be taken. I mentioned in the procedure yesterday as well, you have to take free flow speed. You can do it before the Q study or you can do it after the Q study. But you need free flow speed. Okay. So you need free flow speed and you need vehicles stopped per lane per cycle, and CF will be taken from here. Clear? Okay. Any questions? Okay. This is a sample sheet, observation sheet for observer number 1 basically, but you will see the values from both observers. So the top of the sheet is general information: who is doing the survey, the name of the company, the name of the location, day, time, and so on. Then how many lanes we have, because we are using the number of lanes. The interval IS, okay, the interval is given to the first observer. After how many seconds he will do the counting. Okay. Vehicles stopped, vehicles arrived. Coming from observer number 2, obviously he is counting at that moment. When observer number 1 is using the sheet, he is counting himself. So once the study is finished, he will put these numbers here. Okay. Clear? Okay. How many vehicles arrived, how many vehicles stopped? They will be filled after the study, when the observer number 2 is free. Okay. Then we have the observations for observer number 1. Okay. So you write down the time at which you started the study. Okay. So when you start the study, this is your cycle number 1. Okay. So cycle number 1. Now let's say the first cycle takes 60 seconds. The first cycle takes 60 seconds. And the interval for the first observer is 10 seconds. Okay. So if he is taking observations after every 10 seconds and the cycle is 60 seconds, then how many observations he will take in one cycle? 6, right? He will take 6 observations, one after every 10 seconds. So in one row, in this case, I will have how many values? 6. Clear? Okay. Once the 6 value is done, then the new cycle has started. They will start doing from the new row. Okay. And we said the cycle is a time from the start of the red to the start of the next red, right? So that means the observation should also start from red. Okay. So the observations also start from the red. So you don't break any cycle. Okay. So when the signal was red, you started. The signal just became red. The cycle has just started. You will start from the start of the cycle. Clear? Clear? Okay. And then he will write the observations and so on. This is an example. So you can see the clock time, the cycle number. Okay. How much is the interval between the two observations? How many seconds? You are breaking up. Yes. How many? 60 seconds. Yes. 20. Thank God. You have a problem with everything. Hand, eyes. See, he got healed. Okay. So 20 seconds, right? One observation is taking, or the interval between two observations is 20 seconds. And how many seconds, how many observations in one cycle? How many? 3. So one cycle is equal to how many seconds? Huh? Yes? 60 seconds, right? One cycle is 60 seconds. You see 3 observations, right? In between each 2 observations you have 20 seconds. Okay, 20 into 3. Okay. You can check it, no problem. So once you finish 40 seconds, then it goes to 60. 60 means 0 of the next cycle, right? 60 seconds is the 0 of the next cycle. Okay, so that's why we have this in this manner. Okay, then observations from observer number 2. How many vehicles arrived? This much. How many vehicles stopped? This much. Free flow speed of the road? This value. Okay. And what was this summation VIQ? What was this? Total. Which total? Yeah. Total of these observations. Okay. Total of these observations. Now look here. Total number of vehicles arrived 120. Total in the queue. How? Yes. How is this possible? Total is 120, in the queue 132. How is this possible? So it should be less.
Is it cumulative?
The total is 120, right?
Isn't it cumulative?
Cumulative? In one way, yes, cumulative, but still the total is total, right? If I cumulate the frequency, it will still be the last number with the total, right? If you do cumulative of something, the last number should be the total.
It's dated from the previous time, before 5.
No, it should not happen. I told you yesterday as well. If you have an overflow, that means you have a traffic jam at the signal, we don't do the study at that time. There's no vehicle from the previous cycle.
It's vehicle to gather.
Yes, yes. This observer can count the same vehicle multiple times until it leaves. I told you, queue can be stopped, it can be moving. Okay, so for this observer, anybody who is behind the stop line is in the queue. Okay, so it may happen, he counted first interval 4 vehicles. Next interval, the signal may be still red, or it may still be yellow or green or whatever, but the vehicles have not crossed the stop line yet. Okay, so this 7 may include these 4 as well. If these 4 after 20 seconds still did not cross the stop line, they are still in the queue for it. We will count them. Okay, so these observations have multiple counts of the same vehicle, so this can happen. Okay, vehicle in the queue can be more than the total vehicles. Okay, clear? Okay, what about these 2? Can this be more? Vehicles stopped more than the arrived? No? Can they be equal? Yes. Okay, so this is stopped out of the total. There is no multiple counting here. Okay, he is counting whenever a vehicle comes, he counts it and he will not count it again. When a vehicle stops, he will count it and again he will not count it again. Okay, so every vehicle is just counted once. Okay, so this is always from here. Okay, if all the vehicles stop, they will be equal, but stop cannot be more than the total. Clear? Clear? Okay, so moving to the calculations, the things we have to do. This approach has 2 lanes. I told you is for each direction. This procedure and calculation is for each direction. Okay, so the direction in which the observations are taken has 2 lanes. Signal cycle length is 60 seconds. We already know that, and there are 10 cycles. Okay, how do we know there are 10 cycles? It's mentioned here. Okay, or you can count the number of rows you have. Every row is a cycle. the things which we need are here. The count interval was 20 seconds. So first thing which I will do is we will calculate the time in queue delay. TQ. Okay, that was IS to sum V IQ divided by V total multiplied by 0.9. Yes, how much is this? The units are seconds per vehicle. Okay, these equations give you average delay per vehicle. Okay, so units are always seconds per vehicle. Okay, the next thing we will calculate is VSLC, number of vehicles stopped per lane per cycle. How many vehicles stopped? 75. How many lanes we have? 2 lanes. And how many cycles? 10. How much is this? Okay, next is fraction of vehicles stopped. So vehicles stopped upon total. Okay, the next thing we'll calculate is the control delay itself. So time in queue delay plus FVS into the correction factor. Yeah, that's it. Okay, FVS we know, time in queue delay we know, correction factor comes from this table. So our free flow speed is 35, which is the first row. Okay, and vehicle stop per lane per cycle, this value 3.75. Okay, which is the first column. Okay, so my correction factor is how much? How much is it? 5. Yes. $22.9. And again the units are seconds per cycle. Oh, sorry, seconds per vehicle. Okay, average delay per vehicle.
Doctor, I don't understand. How did you find the correction factor?
From this table. Free flow speed is 35. Okay, got it? And my vehicle stop per lane per cycle? 3%, which is here. Okay, anybody else has a question? Clear? Okay. So we have some more data coming on the next slide. It was collected in a delay study, cycle length is 60 seconds. We have to find out the time spent in queue and the average control delay. So which values they are asking for? The control delay, which is which value? They are asking for which values now? The last one. And there are two parts, right? There are two parts. So part A is about what? The last one is control delay, right? The last one is the control delay. And part A, where is part A? Sorry, the question. So, yeah. Okay. So this is the data they were talking about. So again, you have the free flow speed, the total vehicles stopped, total number of vehicles and vehicles stopped, and these are the observations from the first observer. What is the interval here?
15 seconds.
15 seconds. And what is the cycle length? 60, right? 15 seconds is each interval, and you have 4 values. So 15 to 4, 60 seconds. Okay. And again, you can look at the time as well. And how many cycles we have? Yeah. Okay. Okay, give me the first of all, you have to do the summation now. So what is summation of VIQ? Summation of this table.
Essentially.
Hmm?
Essentially.
Okay, then what is time in Q delay? How much is it? The total is given, the interval is given. Okay. Then vehicles stopped per lane per cycle. Number of vehicles stopped is here. Okay. Number of cycles. Okay. Number of lanes, 1. Okay. 1 lane. How much? 20.3 vehicles per lane per cycle. Okay. Then how much is this? 0.7. Okay. So now we'll be doing 4.7 plus we have to find this 7. Okay. The correction factor, the table is here. Free flow speed is still 35. Okay, they have given the same free flow speed, 35. So we are still here. Okay. Vehicle stopped per lane per cycle. How much was it? Vehicle stopped per lane per cycle. How much was it? 20 point something, right? So we are here. Okay. So my correction factor is -1. How much is it? 4. Okay. Remind me, what is D? What is D? What is this value we calculated in the end? What do we call this? Delay, right? What delay? Total delay. Total? Control delay, right? Control delay includes what? Tell me. There are 3 things included in control delay. I just told you. Huh? Deceleration, acceleration, and what? Q, right? Q time is included, right? Now you see here, if you go back to the previous example, you will see time in Q was less, control delay was more, which makes sense, right? Because control delay includes time in Q delay. Okay. Again, you can see we are adding, right? We are adding. The equation is adding both of them. Okay. But here, if you see the value, the total is less. The total is less, and time in Q is more. Because of what? Why did it happen? Because of the correction factor. Okay. If I go back to the table of correction factor, you will only see one negative value here. All values are positive. Okay. So this can only happen in one case, that the total is less or the control is less and the time in Q is higher. So this can only happen in one case. When the speed is low, you are on the lower side, right? Speed is the lowest, and the number of vehicles stopping is the highest. This is the highest range of the table, right? Okay. So what is happening? We have a signal on a small street. Okay. Why I'm saying it's a small street? Because of the speed. Okay. I gave you a value for the speed for the term project as well, right? That you have to select a highway which has what? 80, speed limit of 80. Why? Because then if you have a minimum speed limit of 80, then eventually the highway is what we are looking for, the type of highway. Okay. So the speed gives you an idea about the type of street or type of highway. So low speed means it's a small street. Okay. So if the signal is causing lot of vehicles to stop on a small street, that means it is basically causing the street to have a traffic jam. Okay. So in that case, the total delay, okay, not this one. This is the delay because of the signal timing. The delay because of signal timing, okay, which is 4 seconds. But the vehicles are spending more time in the queue, not because of the signal timing, because of the long queue. So it's a small street which has a very long queue. Okay, it's a small street with a long queue, and that causes the vehicles to spend more time in the queue than what they would have spent if there was no queue. If they were only depending upon the signal timing, if the delay was only because of signal timing, then it would be less. But because the queue is so long, okay, that the time in queue delay is more as compared to the delay which is only because of signal timing. Okay, it happens, right? So you have a signal and usually you pass through this signal in one go. Signal becomes green, you have arrived and you go. Even if you are waiting there from the red, you go. But if you come to the same signal, when there is traffic jam, the signal keeps on going from red to green and red to green, and you are still in the queue, right? So signal timing is not causing the real delay. The real delay is because of what? The queue. Okay? So if the same signal had less queue, no traffic jam, the signal timing may only cause a delay of 10-20 seconds. But because the queue is longer, the delay is higher. Got it? Okay. So the last one was for the signals. Okay. The last procedure we discussed was for the signals. For roundabout, the procedure is different. Okay. So we are going to use the equation which you see on the slide here. So D means total control delay, but now this delay is because of the roundabout. Okay, the delay is because of the roundabout. Okay, if you look at the equation, you will see the first parameter is C. Okay, so C is capacity. Okay, this C. C is capacity. Capacity of what? Capacity of the lane for which you are calculating the delay. So there is a lane which is entering the roundabout, and I want to find out how much delay will a driver face if he is in this lane. So capacity of that lane is C. Delay of that lane is D. Got it? Yes.
What is the length of that frame?
Sorry?
What is the length of that frame?
Length is not a
Is it
concern.
from intersection to intersection?
Yeah, no problem. Any length. Length is not an issue. Okay. Then the next parameter is T. Okay. T refers to the time which is taken for flow observation. T is a time which is taken for flow observation. Okay. So normally we take the flow for how many minutes? 15 minutes, right? And we want everything in hour here. So 15 minutes means 0.25 of an hour. Okay, 15 minutes, 0.25 of an hour. And this is the case in most of the times. Okay, so T in most of the cases will be 0.25. Clear? Okay. Then we have the parameter X. X is a ratio. X is a ratio. Volume upon capacity. X is the ratio of volume upon capacity. Okay, so we talked about capacity, right? Capacity of what?
Lane.
The lane. So volume of
Lane.
the lane. Clear? Clear? Okay. One small item here, which is this term 5 multiplied by minimum of X or 1. Minimum. Okay. So if your X is 1.3, yeah, 5 multiplied by 1. If your X is 0.7, then 5 multiplied by 0.7. Clear? Okay, so this refers to minimum. Okay. Now, how to find out the capacity? The first table gives you the equations for capacity. Okay, so the selection of equation depends upon how many lanes you have on the road and how many lanes you have on the roundabout. Lanes of the road, lanes of the roundabout. Okay, so the first case, left top, you have one lane of the roundabout, one lane on the road. Okay, second case, you have one lane of the roundabout but two lanes of the road. So if the road has two lanes, then you can see we have different equations for left hand side lane and right hand side lane. Clear? Okay, and same thing in the other column as well. Okay. In all these equations, we are using a parameter which is called VC. All of them. Okay, all of them have the same term, VC. So VC is called the circulating or conflicting volume. Okay, circulating or conflicting volume. Meaning what? Volume on the roundabout. VC is volume on the roundabout. Clear? Okay, sure.
What is volume on the road?
The one, yeah, the one which is going around the road, the one which will pass in front of you. Okay, so that is VC. Clear?
Yes.
Now, you will select the equation according to your case. You will put the value of VC, you will get capacity. Okay, you can only use the value of capacity directly if there is no pedestrian movement. Okay, so if there is pedestrian movement on the roundabout, the pedestrians are crossing the road, then you need to apply the pedestrian adjustment factor to capacity. So you will not use the initial value of capacity, you will use the adjusted value of capacity if there is pedestrian movement. Okay, so how do I get the pedestrian adjustment factor? From this table. Okay, so again it depends upon your conditions. How many lanes your road has? If it has single lane, you will use one of these three. If you have two lanes, you will use one of these two. Okay, so conditions For example, look at the first condition. The first condition is your road has one lane. Your VC, what was VC?
Volume on the roundabout.
Volume on the roundabout. Okay. So if your VC is more than 881, then your adjustment factor is 1. So whatever capacity you have multiplied by 1. If your VC is less than 881 and the number of pedestrian crossing in that hour is less than 101. So VC less than 881, volume of pedestrian less than 101. Then you will use this equation for the factor. Okay, so you put the number of pedestrians here, you will get the factor of pedestrian and you will multiply the capacity with this factor. Okay, clear? You will get the final value of capacity after multiplying with the factor. Okay, okay. In all the equations we are using VC and number of pedestrians. VC is the volume on the roundabout and number of pedestrians, how many pedestrians are crossing. Clear? Okay.
So, what's this PCP per hour?
Sorry?
PCP per hour.
Passenger cars per hour. Passenger cars per hour. Okay. So let's say we have a circulating volume of an approach single lane roundabout. Circulating volume is 650 PCE, passenger cars. And the number of pedestrians crossing the approach is 100. Okay. So we have circulating volume 650 and the number of pedestrians crossing is 100 and the approach also has one lane. Single lane roundabout, approach is one lane, the circulating volume is given, number of pedestrians are given. Clear? Okay, we have to find out the capacity. Okay, and since pedestrian movement is there, we'll find out the adjusted capacity. Okay. First of all, which equation should I use for the calculation of capacity? Okay, the first one, top one on the left, because we have single lane entry, single lane out. Okay, VC is 650. So my capacity is how much? Yes.
190. 190.
590. Okay, all these values are in passenger cars per hour. Okay, how do we make them in passenger cars? We will discuss it in other topic. Okay, but all of them are in passenger cars per hour by default. Okay, you don't have to change anything. Okay, since there is pedestrian movement, so that means I need pedestrian adjustment factor. So first of all, I look for the case. My road has how many lanes? One lane. Okay, so I will look for one of these three cases. Okay. My VC is it more than 881? No. Okay, it is less. Okay, then I look for number of pedestrians. My number of pedestrians is 100. Okay, so that means I satisfy both these conditions. So I will calculate the factor using this. Okay, so how much is the factor here? Zero point. Okay, so my capacity after adjustment means you multiply capacity with 0.99. How much is that? 584. Clear?
Yes.
Okay, any questions? Okay. Moving on, next example, we have delay for left hand and right hand lane. Left and right lane. So how many lanes?
Two.
Two. Okay, and we are calculating the delay of these lanes. That means these lanes are on the road. Okay, they are the lanes on the road. Okay, we have 20 lanes, one conflicting lane. Okay, so which lane we call as conflicting? The roundabout. Okay, the lane in the roundabout. Okay, so that lane has a flow of 600 passenger cars per hour. That lane of the roundabout has a flow of 600 passenger cars per hour. Volume in the left hand side lane of the road 600, in the right hand side lane of the road 400. You can also see it here. Okay, so we have these two lanes. We have to calculate the delay of these two lanes. The roundabout has a flow of 600. Okay, clear? Clear? Okay, and what is this? That we have two lanes, right? So what is this? Third lane? The other direction. Very good. Okay. So which case do we have?
Second.
Huh?
Two lane roundabout.
Two lane entry.
Yes.
One lane out. Okay. So first column, second row. Okay. First column, second row.
Why isn't one lane roundabout? Oh, okay.
One lane roundabout one lane. Okay. So now you can see here, if you have two lanes, then we can have capacity of these two lanes different. Okay, we have two equations. Okay, but if you look at the equations, they are what? Same. So that means the capacity will be same. Okay, for right hand side lane and the left hand side lane. Okay, BC is 600. Capacity is 620. Okay. Okay, if I go to the equation for delay, I needed capacity, now I have. I needed T. What is the value of T here? How much is T? Yeah. Huh?
0.25.
0.25. Okay. So it's, as I said, in most of the cases it's fixed. Okay, unless they tell you that we took the flow for these many minutes and so on. So T is 0.25. It's written here. What was X? What was X? Yes, what is X? Yes, what is X? Volume to capacity ratio. Okay, so you have the volume for each lane is different, right? Capacity is same, but the volume is different. So that means X will be different. Okay, so for the left hand side lane, the volume is 600. This value is given, and you calculate the capacity 620. So X is how much?
0.97.
Huh?
0.97.
0.97. Okay, then for the right hand side, it will be 400. The volume in the right hand side lane is 400. So 0.65. Okay, so then you can calculate the delay. Then we have everything we need. Okay, you will calculate the delay, and since X is different, that means the delay will be different. Okay, so give me the value of delay for the left hand side lane and the right hand side lane. Now what will we do here? 5 multiplied by what? X or 1? X, because you see X for both cases is less than 1. Okay, so 5 multiplied by X. Clear?
Yes.
And this is only here. This is only here. So if your X was 1 point something, we put it directly, no change. Okay, so this X or 1 is only in this bracket. Anywhere else you see X, you will put it as it is. Whatever it is. More than 1, less than 1, doesn't matter. Okay. Delay for left. This is for which one? 54 point? As I said, seconds per vehicle, okay? Seconds per vehicle. And for the other one?
8.7.
Any questions? Okay, so both lanes have the same design, okay, because their capacity is same. So that means their design is same, okay, but their delay is higher in the left hand side lane. Why delay is higher in the left hand side lane? Because of its flow. Okay, now if you compare between them, this is, you know, almost 3 times. The difference between them is almost 3 times. If you look at the flow is only increased by 30% something. Okay, so the delay increases exponentially when you increase or when the flow increases. The delay does not increase by the same amount. So if you increase the flow by 10%, it doesn't mean the delay will also increase by 10%. Okay, the delay may become double. Okay, so it's not a linear relationship. This is non-linear. Okay, and the non-linear meaning the delay increases exponentially. Little bit of change in flow will have more effect on the delay. Okay, in this case the effect is 3 times. Okay, got it? Okay. This is another question. You can do it later on. We have one entry lane, one conflicting lane. Okay, the conflicting lane has a flow of 600, meaning the flow on the roundabout is 600, and the lane has a flow of 400. Okay, so you will calculate the capacity. The case is different now. In the previous question and in this question, pedestrians are not mentioned. That means there is no pedestrian movement. So like we did in the previous question, you calculate capacity and use it as it is. Use it as it is. No need to apply. If the pedestrian is not mentioned at all, that means there is no movement of pedestrian. You don't have to go to the table of the factor. Okay, just ignore the table and just take the value of capacity. Clear? Clear? Any questions? Okay.